Each manufacturer has certain proprietary features that require different erection procedures for its own systems. However, there are certain aspects to the erection of a metal building that are common to all systems. These are presented here and are to be implemented in conjunction with proven individual techniques and sound engineering judgment. The primary structural system of a metal building system is the frame that supports the roof, walls, and all externally applied loads. Several different types of framing systems are used today. Aside from minor individual differences between manufacturers, these systems include single-span rigid frame, usually with tapered beams, tapered beam with Type 2 connections at the columns, continuous beam frame or post and beam, single-span and continuous trusses, and a lean-to system. These framing systems are used for a wide range of building applications. You will find metal building systems used for office buildings, retail stores, shopping centers, automobile showrooms, banks, factories, warehouses, and distribution centers, plus community structures like schools and recreational facilities. Some metal buildings may require special erection techniques because of their particular use. These include crane buildings, structures that integrate various construction materials with the metal building system, such as concrete, brick, stone, masonry, glass, and metal. And finally, multi-story buildings more than 2 stories in height. More applications are being designed with 3 and 4 floors as industry technology advances. A true metal building system is a sophisticated structure. All structural members work together to support each other. MBMA believes structural integrity is best achieved when the components are designed into an integrated system and fabricated by one manufacturer. Therefore, sound erection programs are needed so that the building customer receives the maximum benefits of systems construction. Planning and Safety, Sections 2 and 3. An expeditious and cost-effective steel erection program depends on advanced planning during the pre-construction stage. Each project site should be examined and evaluated prior to material delivery. Alternate solutions to deal with unique site conditions should be developed at this time. A well-planned, clean, and orderly job site will usually trim overall erection costs, create an atmosphere of safety, and offer a perception of professionalism and craftsmanship. Primary project site considerations should include site accessibility, its impact upon material delivery, shakeout and storage, and the mobilization of erection equipment. Soil condition, as it may affect support equipment, water runoff, access to materials, and drying conditions. Utility and support services, availability, and adaptability. Once the site is assessed, a preliminary erection sequence can be sketched out. Back-check events against known site conditions to verify them and to learn about any problem areas. Now that the erection job has been evaluated with respect to the actual physical site conditions, the size of the crew can be determined to do the project most efficiently. Start with a small crew to lay out structural members. Add more workers as required. The type and number of personnel needed for each phase of the erection process should be defined in detail. Careful consideration should be given to scheduling functions that require specialized skills or equipment operators. For example, structural steel erection is usually separate from sheeting and flashing skills. Generally speaking, a small 7,500 to 10,000 square foot building can be erected with one crane and its operator and a 5-man crew, consisting of a working foreman, 2 lead men, and 2 assist men. Buildings over 10,000 square feet usually will require 2 more men in the work crew. The size of the work crew has been determined. Next, consider the potential impact other construction operations will have on your plant and work. You may find it necessary to adjust your personnel and equipment plan daily to operate most efficiently. Now that a workable sequential erection timetable has been set, you can arrange for the tools and equipment needed to complete the building on schedule. To implement a cost-effective equipment program, review some of your critical planning considerations. Is the site ready for the delivery of material? For the unloading and shakeout of the primary structurals, secondary component bundles, and panel pallets? For the positioning of primary structurals so they can be erected in proper sequence? For subsequent bundle and pallet positioning? And finally, for pre-lift ground assembly operations. Don't overlook basic hand tools that are conveniently available. Having proper tools in sufficient numbers to get the job done right will pay large dividends. The erection crew will work faster, better, and more safely with the right equipment. Ultimately, the chances of having to do the work over again will be reduced. Hand tools and equipment must be maintained in serviceable condition. Maintenance functions should be recorded on the tool and equipment schedule. The Metal Building Manufacturers Association Construction Committee has published a recommended basic tool package for 5 to 7 man erection work crews. The list will help you assemble the necessary tools to meet the specific project requirements. Included in the publication are lists of the quantities and types of tools appropriate to the erection of a typical building system. If the steel erector is not furnishing the foundation work, it is extremely important that the dimensional accuracy of the concrete steel interface be verified. Be sure to check all foundation dimensions, including overall size, elevation, level and squareness, anchor bolt placement, and projection. The surest and fastest way to verify these dimensions is with a steel tape and a transit. Acceptable tolerance is usually defined either by the building manufacturer or by a reference in the general specifications. The building manufacturer sets allowable deviations in accordance with the inherent degree of flexibility embodied by his product design. Customer specifications occasionally may set limits for both the concrete and the steel, in accordance with end-use requirements. Foundation level and elevation should be checked with a transit and reference to a permanent benchmark. Overall squareness can be verified with a transit or a metal tape. With the metal tape, a 3-4-5 triangle method or a diagonal check method may be used. Overall, out-to-out of concrete dimensions and anchor bolt locations should be checked with a metal tape. Bolt locations should not deviate by more than 1/8 inch from the given center line of the column references, or by 1/4 inch in any 100-foot run. About 3 to 5 pounds of pressure should be placed in tape. Note that steel tapes are usually calibrated at 60 degrees Fahrenheit and may gain or lose 1/8 inch for each 15-degree Fahrenheit variation above or below this calibration point. Check each dimension shown on the building manufacturer's anchor bolt plan. This includes gauge, backset, and projection, as well as the major grid dimensions. Minor anchor bolt misalignments can be taken up by shifting the columns within the limits of the oversized holes routinely fabricated into the column base plates. In case of major misalignments, contact your manufacturing representative for recommended corrective action. The dimensional accuracy of the foundation and its anchorage points must be verified prior to any attempt to erect the steel superstructure. The precision defined by the tolerance limits is critical to the proper fit-up and subsequent synergistic performance of the system's components. While performing these dimensional checks, it's a good idea to clean the bolt threads, smooth the bearing surfaces, and mark the column numbers on the pier. Doing this in advance will save time and money once the steel arrives at the site. The Metal Building Manufacturers Association strongly feels that the most important single factor in avoiding the pain, suffering, and expense inherent in erection accidents is to develop a safe worker attitude within each individual. The Construction Committee has published a Construction Site Safety Information booklet. It contains a number of field practices specifically aimed at encouraging the safe worker attitudes within all field personnel. There's no substitute for a committed safety program specifically tailored to project requirements and geographic conditions. All applicable federal, state, and local safety statutes, ordinances, codes, and regulations should be observed, including OSHA stipulations, and any applicable local, national, or international union rules, customary practices, or requirements. Material receipt, Section 4. When fabrication is complete, all building components are thoroughly inspected. They are carefully bundled and crated to prevent damage during shipment. The manufacturer will notify the builder in writing when a loaded unit is ready to be shipped to the job site. The notification should include the job number, routing, type of unit, unit number, itemized weights, total weight of the unit, and the date of departure. Care should be taken not to schedule erection crews and equipment until the builder is certain of the quantity and delivery date of the material. The auditing of materials is extremely important. The builder should verify the materials in the shipment against those listed on the shipping documents. A bill of material accompanies each unit shipped with all items included on the respective unit so marked. Package tags should be kept for later verification if necessary. If damaged material is discovered during unloading, make a descriptive notation on the shipping papers. Have the carrier sign them. Failure to note damage on the shipping papers will indicate the materials were received in a satisfactory condition. If there is concealed damage, save the damaged articles, including all packing material. Notify the delivering carrier immediately. Double-check each load. Finding that materials are missing or damaged once erection is underway is a costly proposition. Unloading materials is the first step in the actual erection of the building. Always have the proper equipment on hand when unloading. The site conditions, space to maneuver, nature of the materials to be unloaded, and other related factors will determine the type of equipment best suited to the situation. Ordinarily, unloading is done by cranes. Under the right circumstances, however, forklifts may be more practical and economical. One piece of equipment essential to unloading sheeting is the spreader bar. With either a forklift or crane, the spreader bar reduces the possibility of buckling long sheets as they are being lifted. When lifting sheeting, pickup points should also be protected so that the edges of the panels won't be damaged. Chokers, slings, clamps, or shakeout hooks are normally used to unload primary and secondary structural steel. The unloading equipment should be positioned at the pickup or balance points of the load to be hoisted. The weight and shape of the load determines pickup points. Never pick up a panel bundle at its extreme ends. This can severely damage the major panel ribs. A belt or protected edge should be used to avoid damaging the panels. Always pick up panel bundles at the designated pickup points and position the slings around the sideboards. Remember, damaged parts cause delays. Unload all materials carefully. Do not drop, but rather lower them slowly to the ground. A good job of planning the unloading sequence and material layout scheme will eliminate extra crane moves, extra handling of material, much wasted time, and possible damage to material. Give the crew a sketch of the placement locations and/or storage areas for the structural members, panel, trim, bolts, hardware, and insulation prior to unloading. There are two basic unloading techniques. One is unload and store. The other is unload and erect. If the erection process is going to be delayed, Building materials must be properly stored so that they won't be damaged. Ground storage structural components are subject to moisture and dirt. Since structural steel is usually primed with only a shop coat, it might have to be cleaned and repainted at great cost. All materials should be placed on blocks. This will also help assembling materials and attaching them to lifting apparatus. Even greater care must be taken to protect sheeting and trim that are stored. When storing sheeting, one end of the bundle should be elevated at least 3 to 4 inches off the ground. Sheet bundles should be placed above the terrain so that air can circulate from both ends. Proper storage does not ensure moisture prevention alone. Inspection and appropriate action is the best insurance to avoid damage from moisture corrosion. Care must be taken when storing and handling insulation materials so that the facing doesn't become damaged and the fibers begin to deteriorate. Keep the material packaged and covered with a tarp until it is erected. No one should be allowed to walk on materials stored on the ground. Time spent cleaning soiled materials could be better spent on erection. Job site theft is costly and irritating. Small tools, erection materials, and hardware should be locked up when they aren't being used in a field warehouse or storage vehicle. Larger items can be protected within a lighted area. A watchman might also be inexpensive insurance. If the erection of the building is to start immediately after unloading, the primary structural steel should be laid out for easy pre-assembly and setting. When possible, leave an access area throughout the full length of the building so material will not have to be handled more than once. Many erectors know that a man on the ground can work twice as efficiently as a man working in the air. It will help the builder if he can assemble as many components as possible that can be handled safely while they are on the ground. For a relatively small structure, the builder may want to erect it immediately upon unloading with a minimum amount of pre-assembly. This can minimize the amount of time a rented crane is needed on the job. It may be cheaper on smaller jobs to assemble smaller parts after rather than before the erection of the primary structurals. Pre-assemble everything possible on the ground. Ground pre-assembly is safer and takes a lot less of the crew's energy. Columns can be pre-assembled with clips, brace angles, and other miscellaneous connections. The builder will have to decide on how much pre-assembling can be done depending on the size and type of job. Rafter sections can be bolted up as they are laid out for picking. All splice bolts should be installed and tightened under unstrained conditions. Make sure all pre-installed high-strength splice bolts are properly tightened before the structural sections are hoisted. Connection bolts for miscellaneous materials need only be finger tightened in pre-assembly. All bolts, however, should be fully tightened upon completion of each connection. Always follow the manufacturer's specification for bolt tightening. Flange brace angles also can be loosely bolted to the rafter sections while they are on the ground. Post and beam end wall materials can be laid out at each end of the building. They can be fully or partially pre-assembled for tilting up into place as a unit or unit sections. Girts, purlins, eave struts, and door jambs should be broken out and divided along both sides of the building according to the requirements of each bay and rebundled if necessary for handling. Panel bundles, trim, and related components should be spotted outside the foundation perimeter for erection later. Shake out wall and roof rods in their respective bays. Run the nuts down, then back them off to clean the rod threads. Pre-assembling nuts, bolts, and washers can also save time later. Structural steel, Section 5. Safe and efficient structural steel erection begins with the first braced bay. MBMA strongly suggests that when possible, the first bay be completed from sidewall to sidewall before erection continues on the remaining framework, except for extremely wide buildings or where impractical. That includes primary frames, purlins, and eave struts, and loosened permanent rod bracing. The framework should be adequately braced with properly anchored construction tie-offs. Further, it is mandatory that the builder adequately stabilize all erected components until the entire structural shell, including the sheeting, is complete. Nearly all construction phase failures can be attributed to inadequate construction bracing. Once the frames for the first braced bay are set and cable braced, all of the secondary structurals should be installed. Once the purlins and eave struts are tied in, any permanent roof and wall bracing should be installed in a loosened condition. All temporary construction bracing must still remain in place and tight. Secondary structural connections should not be tightened until the first bay has been plumbed and aligned. Necessary alignment adjustments may be made by tightening or loosening the temporary cable bracing. After the bay is completely plumbed and aligned, the secondary structural connections may be tightened to specification, along with the permanent rod bracing and the anchor bolts. Permanent rod bracing is not recommended as temporary construction bracing or for purposes of plumbing. The quickest way to align a building is to plumb the first bay erected. Then make periodic alignment checks and adjustments throughout the balance of the structural system based on this benchmark bay. This will make all succeeding connections easier. Plumb is defined as a variance not to exceed L300. There are several accepted plumbing methods. Use a transit to achieve the greatest accuracy. After the first braced bay is completed and plumbed, the builder may continue with the erection of the remainder of the structure. Again, the temporary construction bracing should still be in place and tight in the first bay. MBMA recommends that all purlins be installed as the building progresses. This diagram reviews the initial steps of metal building erection. 1. The first interior frame is set with temporary tie-offs, shown with blue lines, in place. 2. The second frame is fully erected with construction bracing. 3. All of the secondary roof and wall structure is installed. 4. Permanent rod bracing, if required, is loosely installed. 5. The first bay is plumbed and aligned with all connection bolts tight and permanent rod bracing, if any, snugged down. Do not tighten the rods too much. It may not be possible to pull all the sag out, especially with larger rods. 6. Erection of succeeding frame lines continues with the same procedures as described before. In order to reduce the number of lateral crane moves, it may be practical to continue with the erection of one half of the structure for the entire length of the building. Then, work back down the opposite side in the same prescribed manner to finish off each frame line. This method is fully acceptable as long as adequate temporary bracing is used throughout the length of your erection path. Once the first bay is erected, braced, plumbed, and bolted up, it becomes the basis for erecting the remaining frames. Set all columns you can reach without moving the crane, but only for those frames which can be completed or braced during the current day's work. Freestanding columns are hazardous since they can be blown over by a gust of wind. Put washers and nuts on the anchor bolts, but do not yet tighten more than finger tight. If 2 cranes are needed for erection, it is suggested to have one at the site ahead of the other to shake out the material. If 2 crews are required, the second crew can be kept busy by following up the main erection sequence with the distribution and bolt-up of fill-in materials. When all purlins are filled in as erection of the frame lines progresses, the roof bundles can be spotted above the framework, if the roof slope permits, normally under 2 and 12. This can save valuable time during sheeting erection. It also reduces the crane time. A wide multi-span frame structure will require additional men to follow up the main erection sequence with the installation and bolt-up of fill-in materials in order to keep pace with the main framing. Also, if roof slope permits, plan to spot the roof panel bundles as structural steel erection continues. The crane may not have enough reach to properly place the bundles later. When placing roof panel bundles on the structure, make sure they are spotted over the primary rafter sections with purlins blocked to avoid structural damage to the unbraced light gauge purlin members. These operations should be repeated over the entire length of the building. The remaining end wall is raised by the methods described earlier. If for some reason the wall can't be sheeted immediately after the girts are erected, girt flutter may be averted by blocking or by looping a continuous length of rope around the eave strut or end rafter and to each girt, and then secured. Walking or climbing on girts or girt clips also introduces severe stresses. The repair of carelessly damaged material is always more costly than measures of prevention. Prior to installation, plan the positioning for each girt line in order to properly accommodate the framed openings. If a girt line must be changed to accommodate framed openings, try to maintain this positioning throughout the length of the visible wall plane. This helps avoid erratic screw lines and stripped-out screw holes in the sheets. It is important to align the face of the base condition with the outside faces of the girt system to ensure proper alignment of the base for the wall sheets. This can be easily accomplished with a plumb line. Avoid setting base angle inside concrete edge. Otherwise, panel dimples can occur when fasteners are driven. Upon completion, the skeletal structural steel should include all primary and secondary framing with all flange braces, rod bracing, girts, purlins, support angles, sag rods, and other miscellaneous structural components in place. A final alignment check should be made before sheeting begins to see that all member structures are plumb and aligned properly. Once the panels are installed, it is difficult to correct any structural steel alignment problems without removing or damaging the sheeting. Give the structural steel a final connection inspection to ensure all bolts are in place and properly tightened. Bolt grades and tightening procedures vary from connection types. The primary high-strength A325 or 490 bolts must be tightened according to specific procedures, while secondary bolts are not. The builder must be thoroughly familiar with each. He must also be aware of the connection inspection procedures stated in the specifications and the material and procedural requirements called for on the erection drawings. It's a good practice to initial all completed connections. This way, a temporarily incomplete connection will not go unnoticed. A check should also be made to ensure that there are no damaged members which could require removal of the sheeting to repair. Some damage may be considered superficial without effect to structural integrity. When in doubt, consult with the manufacturer. Modifications should not be made to any structural members that are damaged or do not fit without approval from the proper authorities. Sheeting and trim, Section 6. The owner's acceptance of any building depends on its finished appearance. Sheeting, trim, and accessories are the most conspicuous elements of construction. They must be installed with the greatest of care. Just as with structural steel erection, the crew should go over the manufacturer's detailed installation prints before sheeting begins. This will ensure proper and efficient installation of panels and trim and minimize the probability of most common errors. The tools, materials, and techniques of proper sheeting and trim installation are simple. By meticulously following manufacturer installation instructions, the builder can avoid unnecessary and expensive callbacks. It is strongly recommended that the wall sheeting be installed first. Wall panels lend a high degree of rigidity to an incomplete structure. Before the first wall panel can be installed, the base condition must be in place. Purlins can be aligned with a sag angle or blocked. Girts, especially those spanning wide bays and wings, have a tendency to sag. To align, it is recommended that the erector shore them up with wood struts. With some panel profiles, fasteners form a very visible pattern down the length of a building wall. It is important to the building's appearance that straight screw patterns be maintained throughout the visible length of a wall surface. A quality appearance can be obtained by pre-drilling the wall panels. This method consists of stacking sufficient panels in a pile for a single bay. Pilot holes are then drilled through the entire stack in one operation. Pre-drilling does more than assure correct alignment. It saves time in fastening since only the girt material must be penetrated. The hole in the panel acts as a pilot for the fastener as it starts to drill. Pre-drilling is also a deterrent to driving the fasteners through the panel and missing the girt. Before drilling the aligned stacks of panels, measure the girt spacings. Start at the top of the base flashing and measure the distances to the center of the exposed faces of the girts. These spaces should be constant for the entire visible wall surface. Then, drill a test sheet and check for proper alignment before drilling an entire stack. The test sheet will be your template. When aligning panels for pre-drilling, don't slide them in the stack. Lift them to avoid scratching the finished surface. The drill size should be slightly larger than the fastener thread diameter. Pre-drill only those panels you expect to erect that day. Be sure to remove the drill filings within the stack, which can discolor or stain the finish. Wall panel installation should begin at the end of the building farthest from the point of maximum sight exposure, progressing toward the prevailing view. Thus, the shadow of the panel lap joint will not be apparent when viewed from this perspective. Blanket insulation and sheeting should be installed simultaneously. Start at one corner of the building with a roll of insulation wider than the sheet width. Insulation should wrap around the corner of the building and extend beyond the lapping edge of the steel panel. This insulates the corners of the building and also moves the insulation joint beyond the point of the metal panel lap. Temporarily secure the insulation and smooth out the facing wrinkles prior to fastening the panel. Be careful not to stretch fiber blankets too tightly. This will compress it and reduce its thermal performance. Trim the insulation to length before installing the wall panels in order to avoid an inadvertent water wick. Each successive roll of insulation should maintain the same amount of panel overlap. When joining successive rolls, pull the tabs evenly outward and glue or staple the tabs together. When stapling, fold the tab over and staple again between the first row of staples. To help maintain the integrity of the vapor retarder, tape the joint when specified and repair any facing punctures or tears. Condensation is the biggest obstacle to achieving maximum thermal performance. MBMA has published a condensation fact sheet to help you understand and control this potentially costly problem. Always install the insulation with the facing toward the warm side or interior of the building. There are many insulation options other than blanket available to owners today. Each system should be independently evaluated with respect to its in-place economic value and its overall system compatibility. Precise vertical alignment of each installed sheet must be maintained prior to final fastening. Misalignment of one panel will cause progressive problems throughout the remainder of the sheeted surface. When erecting wall panel, mark panel width modules at the top and bottom of the fastening base. This helps maintain panel dimension as each sheet is installed. With long panel lengths, it will be necessary to measure coverage at the middle also. The end wall panels may have to be field cut or backlapped to fit. Many times end wall panels must be field mitered. Careful layout, especially on steep slopes, will ensure against panel gaps and sawtoothing. Panel fasteners should be installed in strict accordance with the project drawings. After the wall sheets are secured in each bay, the wood girt shoring may be removed. As the wall fasteners penetrate the girts, even when pre-drilling panel stacks, small steel shavings are often scattered onto the panel surface. These particles are magnetized and adhere to the wall surface. If they are not removed, they will cause rust spots on the finish. These are difficult and time-consuming to remove. A quick wipe with a clean cloth at the time the fastener is driven will prevent this problem. Also, make sure that all drill filings on the base flashing are swept off at the end of each workday. The installation of the eave and rake trim flashings and closures closely follows or occurs simultaneously with the sheeting operation. Trim has an enormous impact upon the appearance of the completed building. Light gauge flashing and trim materials are extremely vulnerable to damage from mishandling. The builder's attitude toward quality is the biggest factor in determining the finished appearance of a structure. If the trim is not true, it detracts from rather than enhances the final appearance. The use of string lines, module markings, or line of sight and qualified personnel is always good insurance. Trim, flashings, and closures are usually fastened with sheet metal screws or pop rivets and sealed as indicated by the project drawings. Don't pass up the opportunity to pre-assemble as much trim as possible on the ground. As with the structural steel, your efficiency can be greatly increased by assembling as many pieces of trim as possible on the ground. But don't do more than can be safely handled without risk of buckling. If electrostatic wrap is used, it should be removed from the trim and flashings immediately. If it bakes in the sun too long, it becomes extremely difficult to remove and increases the possibility of damage to the finish. Sheeting the roof is the single most important function in the erection of a structure. The roof must protect the building interior for many years. Yet it's claimed that leaking roofs represent more than half of all recorded construction claims. Proper care in layout, handling, and installation of roofing materials should be demanded of all crew members. As with the walls, roof sheets and insulation are installed simultaneously. The starter roll of insulation should again be wider than the starter sheet width. This overlap should be maintained throughout the length of the panel run to keep the insulation seams ahead of the lap joints. The ceiling tabs should be stapled or glued using the methods previously described. Sheet width increments should be laid out and marked for the entire run of roof panels. This will keep all sheet placements in alignment. All sheets should be positioned as indicated by the project drawings. Manufacturer instructions for the installation of eave, rake, and ridge details must be followed closely. Care must also be taken with the alignment of opposite slope panel ribs. This is especially true when working with handed panels. Proper alignment is mandatory for proper fit-up and integrity of the ridge condition. When possible, lay out the roof so that the lap joints are on the lee side of the most severe weather direction. This will reduce the possibility of a wind-driven rain leak. The builder is supplied with 3 weapons to prevent roof leaks: tape sealant, tube caulk, and closure strips. The proper application of each is very important. Follow the manufacturer's recommendations for sealant, closure, and fastener placement. Sealants should be installed during erection of the lap sheet. If a tape is installed too far in advance, it can dry out or collect dirt, both of which could interfere with the sealing of the 2 metal sheets. To ensure a tight seal, rag wipe the panels to remove any oil, dirt, or moisture. Double to single sealant thickness transitions should be accomplished by butting or feather edging. A tape sealant should not be stretched during application. Remember to remove the release paper just prior to panel nesting. The end result of an installation mistake will be a faulty lap seal and a costly leak. Tube caulk should be used per drawing specifications and as necessary in accordance with sound erection practice. Exercise extreme care when walking on installed roof panels. Roof traffic must be confined to panel flats, preferably at the purlin lines. Never walk or stand on the major panel ribs. This not only illustrates very poor erection practice, but it also opens up the lap joint and destroys the weather tightness of the roof. Never apply a concentrated force to any single major corrugation for any reason. Use walkboards to distribute loads over 2 or more major corrugations. It is imperative that drill filings be swept from the roof at the end of each workday. Drill shavings, either from saw cuts or drilling and fastening operations, may become embedded in the roof coating. Within a matter of hours, rust can develop. This rust could eventually stain the wall finish, too. There are many choices available to owners today in both roof systems and fastening devices. Each has its own merit and impact upon appearance, insurance requirements, life cycle value, and cost. Most utilize sheet metal fasteners in varying locations and capacities. Proper installation of these fasteners can only be accomplished with the proper equipment. This is a high-torque screw gun, primarily used for the installation of self-drilling fasteners. It's equipped with a magnetic socket and an adjustable clutch, or a depth-sensitive nose piece. Manufacturers of self-drilling fasteners recommend that these guns run between 2,000 and 2,500 RPMs and a minimum of 4.5 amps for peak performance in driving self-drillers. This gun is for use with a self-tapping screw. It is a low-speed gun of approximately 500 RPMs and is also equipped with an adjustable clutch and magnetic socket. This gun must not be used in driving self-drilling screws. Self-tapping sheet metal screws are often used for making sheet metal to sheet metal connections. They also may be utilized for sheet metal to structure connections. When utilized for sheet metal to structure connections, pilot holes must be drilled. Self-drillers are used to attach panel, trim, and hardware directly to the secondary structural framing without pilot hole drilling. Some manufacturers do provide drillers for side laps. Special self-drillers should be used for making sheet metal to sheet metal connections because of their tendency to strip light gauge material. Even with the right equipment, it is possible to strip a few holes. When this occurs, the fastener should be removed from the hole and replaced with a larger size screw, usually one with a larger diameter. Color-coordinated pop rivets also can be used in fastening sheet metal trims and flashings. Accessories and final inspection, sections 7 and 8. Accessory items are chosen for their function and appearance. Most become integrated into the general building appearance. For this reason, they must be installed with the same care and attention as the paneling and trim. Accessory items typical to many structures include framed openings, personnel or service doors and windows, skylights and wall lights, interior treatments, ventilation devices, overhang and fascia systems. Recheck the erection drawings for the location of each accessory and be sure to follow the manufacturer's instructions explicitly for installation. A thorough inspection of the entire facility should be made by the builder prior to the owner's final acceptance tour. All necessary corrections and adjustments should be made at this time. Things to look for include the integrity of structural and sheet metal connections, missing components, damaged components, trim appearance, accessory operation, marred finishes, leaks. Finally, the job site should be left in a condition that would satisfy you if you were the owner. A littered site detracts from the appearance of a newly completed building. No job should be considered complete until all construction debris is cleaned up. Conclusion, Section 9. A clean, well-organized job site also promotes safe work habits among construction workers. Safety cannot be stressed enough. Workmen should be trained to use the proper safety equipment and procedures. Proper safety gear for the specific job should be enforced at all times. Safety cannot be solicited through a booklet, a rule, or a program. It's embodied in awareness, responsibility, commitment, training, and supervision. It's the best insurance for keeping everyone in business. Some of the more important aspects of erecting a metal building have been highlighted. Potential problem areas have been discussed with the hope that they can be avoided.